Hi, I'm Therese, and today we're going to build Project 6 Light Theremin. We will use a piezo and a phototransistor to change the pitch of the sound in relation to the amount of light that the sensor detects, which will resemble our theremin. A piezo is like a small speaker that can create sounds in different pitches using a small membrane that vibrates when voltage is applied to it. We will use a built-in library called tone that is able to change the frequency of the digital signals in order to generate different pitches. This is another method of studying analog values instead of PWM, which we used in our previous chapters. Instead of varying the pulse width, which we do when using PWM, we will vary the frequency of a pulse with a fixed width to generate different pitches. A shorter cycle means higher frequency and higher pitch, and a longer cycle means lower frequency and lower pitch. If you look at page 71 in the project's book, there is also an illustration that compares PWM with frequency variation. The other main component is the light sensor, which is the same that we used in project 4. So check that video out to learn more. Let's create the circuits. Make sure that you don't have anything connected to the board. I've started with putting power and ground here on these two lines, so we have power and ground all the way here. Starting with the piezo, I see that it has two legs, and one leg needs to go to ground and the other to a digital pin to get 5 volts. I'm going to place it here pretty far to the right on 2 different rows so that we have place for the wires to the left. And remember to notice which number of the rows they're in. So I'm putting them here on 6 and 10. So now my wires need to go on 6 and 10. I can see that I just have some space left. So I will use 6 for ground. Then I'll take 10 to digital pin. I will use digital pin 8 since we're not using PWM. There. Now I have the piezo connected from ground to digital pin 8. Then I will connect the light sensor in the same way as we did in project 4. I notice which leg is the minus side and which one is the plus side. And then I place them on 2 different rows. I'm actually gonna do this. I connect the power side to the power line. And then I use the resistor to connect to ground. Then I need to measure the signal, so I will use a wire to connect analog pin 0 to the ground side of this small circuit. So now I will always measure the signal from here. And that's it. Now let's connect the board to the computer. If we look at our code, we start by calibrating the sensor's maximum and minimum value. This is because the ambient light can vary depending on where you are, so the first seconds are spent on identifying the highest and lowest value of the light at your current place. We do this by constantly looking for the highest and lowest value during 5 seconds and storing them in variables called sensor high and sensor low. To keep track of the time, we use a function called millis, which returns the number of milliseconds passed since the Arduino board began running the current program. While the time that has passed is less than 5,000 milliseconds, execute the code inside the while loop. To read more about while loop, visit arduino.cc/while. After we've finished calibrating the light sensor, we go inside the loop. Here we start by reading the light sensor value. Then we'll map the value to a matching pitch using the map function and tell the piezo to play the tone using the tone function. Now that you have learned how to make sound with your piezo using a phototransistor, you can try to modify your project. Replace the phototransistor with a potentiometer and turn the knob to hear different sounds. Note that in this case, you don't need to use a capacitor with a potentiometer. You can even try to play your favorite song using this project. If you manage to do that, share it with us on social media. Next time,